All right, let's solve this one together. For these compound circuits, the best way to start is to do the small, either parallel or series sections and sort of boil it down. So the resistance for two parallel 2 ohm resistors is what? Yep, so this is equivalent to 1 ohm. How about a 2, 4, and a 4 together? That's also 1. If you're not sure why, it's 1/2 plus 1/4 plus 1/4 equals 1 over, thank you, and that's just going to be 1, okay? So that's 1. This top path, then, is a series of 4 1 ohm resistors. So this top path has an equivalent resistance of 4, correct. This middle pathway is a series of 2 resistors, 3 plus 1, so this is also 4. These 2 pathways are parallel, so when you resolve these 2 paths, what do you get? 2, that's correct. So this whole thing right here is 2, and then we're going to add this series 2 ohm resistor, so total resistance is
4.
Okay. Now if we use Ohm's law, V equals IR, what's the current?
6 amps.
Right, good. So 24 equals I times 4. So that gives us 6 amps coming out of the battery. That 6 amps will hit this junction.
3 and 3.
Yeah. Now, the reason it's 3 and 3 is?
They have the same equivalency, the same equal.
Correct. This path has a resistance of 4, and this path has a resistance of 4. So yes, indeed, it will split up evenly. So 3 amps and 3 amps. How will those 3 amps then split here, here, and here? Go ahead, Perry.
1.5, 0.75, 1.75.
That's correct. It's going to be a 2 to 1 to 1 ratio. Another way to do this is to look at the voltage drops and then figure this out. So let me show you. We'll finish this up here in a minute. What would the voltage drop be across this first resistor using V equals IR?
12.
Yeah, 12. Sorry, I missed that. So that's 12 volts. What would the voltage drop right here be using V equals I times R? 9. And then this whole parallel section has to have a voltage drop that's the same for each pathway. So we have 24 volts available. We've used up 12 plus 9. What's 12 plus 9? 21. So how many volts do we have left? 3. Then you can do V equals IR, and indeed you get 3 halves, right? 3 halves of an amp and 3/4 of an amp, right? And 3/4 of an amp, and you can check that. What do you get when you add those up? 3 halves plus 3/4 plus 3/4? 3, which is what we had coming in. Okay? If we do the same thing, we follow this around. This is the same path, so this is 3 amps. And that will split evenly, right? Because it's the same resistance, so 1.5, 1.5. Comes back to 3. If we do our voltage drops, we've got 3 here, 3 here. This section, sorry guys, this section is 1.5 times 2, which is 3 volts, and another 3 volts here. Ooh, all those 3 volt drops. So if I were to add this whole full big loop, 12 plus 3 plus 3 plus 3 plus 3 equals 24. Okay? So the marking period exam compound circuit will be very similar to this. You can do this. You should be able to do the one on the exam tomorrow. Good? Yeah, when you add the 12, it does. Tyler? no double battery problems, that is correct.